Welcome to chapter number 12, Incident Analysis. Typical agenda that we'll be following today. First, I'll summarize the last lecture and chapter in review. Then I'll get into what the lecture and chapter objectives are for this particular chapter. I'll get into the lecture itself, and I'll summarize with some review questions. So in last lecture, we started to get into incident handling. We started to talk about incident handling because we can't block all of the different types of attacks that are going to come into our organization. We're going to pick and choose our spots in some situations. In terms of the controls that we deploy for an organization, we don't have unlimited resources and that type of thing to deploy all of the types of controls that we want to deploy. Instead, we got to deploy the controls that we need, and sometimes what will happen is that an attack will slip through and actually affect our IT systems and affect our information assets. So we talked about the major components of dealing with an incident. We understood the incident handling lifecycle, so all the way from preparation to documentation and that type of thing. We understood how to prepare a basic policy outlining the methodology for handling an incident. We started to talk about the report on the incident that can help improve preparation for a similar incident in the future, and the basic elements of disaster recovery and business continuity planning. Now, this is something that a lot of you may not get into in the early stages of your career, but this is something that is actually very important to know. And it's offered in more depth in later courses within the Masters of Cybersecurity program. So in this particular lecture, we're going to go from incident handling, knowing what incidents are, the general process of handling them, to a little bit more granular look as to how do we actually analyze the incidents and analyze them in a fashion that will actually enable us to prevent future incidents from occurring. So we'll talk about the source of information within popular operating systems that often serve as a basis and foundation for analysts to use and employ analytics techniques such that they can understand what happened within a particular incident and deploy the appropriate controls so that that type of incident never occurs again. We'll look at how we can extract information from specific systems, such as different operating systems like Windows and UNIX and so on. We'll talk about how we can create timelines indicating the pattern of event and provide examples of evidence of attacks on multiple applications. So remember, throughout the class, we've been talking about this information security model, and we've talked about how it has 4 different components in it. Within an IT system, there are information assets that are being stored, and then there are vulnerabilities that are associated with that particular IT system. Now, our goal as information security professionals is to deploy the appropriate controls around the IT systems in a fashion that will actually enable attackers to not get into the system and protect the system as much as possible. Because the attackers will be using a variety of different threats that will try to break through the controls or bypass the controls and get to the vulnerabilities in the system to exploit them and cause damage against our organization. So can we stop all of these attacks that are coming in? Probably not. So how do we exactly handle these incidents? That's something we talked about in the previous lecture. And in this lecture, we'll talk about how do we analyze these incidents to prevent future ones. One of the basic mechanisms for analyzing incidents is to do what's called log analysis. And most applications and operating systems provide logging mechanisms. And essentially, logging mechanisms will record the status information about particular events that are happening within that IT system and on the network in general. There are various uses of log information. So software developers use logs to ensure that the application is behaving as expected. Is it generating the appropriate outputs? Is it doing the things that it's supposed to do? It will dump the outputs of an internal command to the screen, and this is something that I showed you in the shell scripting lecture, and you can start to debug it accordingly. Systems administrators will do a performance analysis on a running application. They'll make sure that the application has enough memory and disk space to run appropriately. So they'll go ahead and look at logs, see how the system is behaving, and make the appropriate changes as needed. They'll also use logs in the analysis stage of an incident. It's probably the first desired item of information during an investigation. So within the Windows system, the logs are referred to as event logs, and there's something called the event viewer application. And it's a native user interface to actually look at these logs. And there's many other tools that are available as well. And these may provide improved features to dig into event log files. So the event viewer is going to look something like this. If you go to the control panel and go to the event viewer, in the navigation pane in the left pane, you can go ahead and start to look at the different logs that exist on this system. And the administrator can create custom views and focus on specific targets. So the home screen is in the center. You can start to see all of the different aspects of the system and see all of the logs that are being generated from that particular aspect of the system. And this can give you an idea as to what a normal set of activities look like and what abnormal sets of activities look like. If you see different types of information that you've not expected or not seen before, and it's in the event log viewer, you can start to get an idea of whether or not your system has been breached and how to deal with that incident accordingly. In the event viewer home screen, there's also the summary of administrative events pane, and this pane contains a breakdown of the number of events per event type. If the administrator expands the event type by clicking on the plus button, as you can see on the left-hand side, the number of events within that particular event type is broken down even further by event ID. And event IDs are classes of events under a specific type. So you can see that there's different event types that are here. So errors, warnings, information, audit success, and so on. And you can start to click and see exactly what breaks down, what kind of information is seen within each of these events. The summary of administrative events pane contains a breakdown of the number of events per event type, and the node for each type can be expanded. It shows the number of events that fall under that particular event type. And event IDs are classes of events under a particular type. What you can also get into is the recently viewed nodes pane. And in this pane, what you can see is the latest event logs that have been viewed. It contains a description of the view, date of the log file, when it was last modified, the file that was when the file was originally created, blank date lines that indicate that the file was never created, or log entries that have never been appended to the file. So you can start to see all of this information, such as the description of a particular file, when it was modified, created, and so on. And many security analysts, what they'll actually do is see if there's unknown files or nodes that have actually appeared here, and see when they were last modified and created. And those are telltale signs or indicators of compromise that the organization has been breached in that particular area. You can also get log summaries. It describes the attribute of each log file currently kept by Windows. And there's a size and maximize column, how much space is left for growth in the log file. Files nearing maximum indicate that records are rotating and therefore likely being lost. So you need to consider what's called log life. How long is a log actually existing? And remember, you can actually create scripts that will automatically monitor the information within a log file. So the types of event logs have been a default since Windows XP. There have been application logs, so logging information from third-party applications, and Microsoft applications not part of the OS core distribution, such as video game logs, office logs, and so on. There's also security files that are default login and logout attempts. It can be configured to log data file activity, creation, opening, closing, and so on and so forth. You can also have system event log files. It holds the operating system log messages. So network connection problems or video card driver errors and so on and so forth. Now where this becomes useful and why we're talking about Windows specifically is that in an enterprise environment, many organizations will actually have many Windows machines for the employees within the organization. Systems administrators may be more Linux, may favor Linux more regularly, but within an organization, people will actually, the end users will actually prefer Windows. So we need to know that the different types of logs that are available within Windows systems. In Windows 8, they added in 2 more log files, such as the setup node and then the forwarded events log. And the setup nodes stores logging information regarding installation and software applications, and the forwarded events log we'll discuss in a little bit. Now, what you can do is that with these logs, you can start to conduct what's called forensics. And remember, there's an entire concentration within the Masters of Cybersecurity program for forensics. And there's a screenshot from a compromised machine in this particular slide right here. And what we can see is that the computer had McAfee antivirus running on it, event ID 5000. So you can see that right over here. Now, in the exported log, there are more event details that are not available. However, it's included information points to virus scan enterprise as culprit. the systems administrator in an organization would know. The AV at the time of this incident was 5.4.1 compared to the 5.3.0 that was shown in the log. So the virus scanner was not up to date on this particular machine. So the security analyst, what they're doing, or the systems administrator, what they're doing, is they're actually breaking down these types of clues or cues as to what was the incident that occurred and why did it occur. In this situation, the log files point to the fact that there was an outdated antivirus that was available, that was on this particular machine. Now, as a systems administrator, you can implement the appropriate mechanisms of updating that particular antivirus. So, an internet search of event ID 5000 in connection with McAfee, the error is possible if on-access protection did not start up successfully. And this is the piece that keeps the machine from getting infected in real time. So the follow-up that the system administrator can do is, was the antivirus up to date? Or if it was the antivirus application running on this machine at all? So these are the types of things that a systems administrator can do to break down exactly what happened within a particular attack and make sure that this doesn't happen again. So you can see here the 5.3.0. These are all different things that a systems administrator actually has to research, and this is actually information, the types of information that I ask you guys to actually research on your own for, say, some of the assignments, and making sure that the assignments are making sure that the information you need, you actually start to Google it and look for external resources and research, because this is something the systems administrators actually have to do at their job. They have to look up information. Not all of it's going to be provided in a book. They have to look it up and make sure that it fits in their particular situation. So in this situation, the system administrator can start to delve into the different types of information that's provided by these log files and make sure that they use their domain expertise or their rich expertise and training to ensure that this type of attack is mitigated appropriately and doesn't happen again on other machines or ever again on that organization. Now, event criticality is log messages that are tagged with labels indicating their level of urgency. And you can go into the custom view folder and administrative events custom view. And it's installed by default on Windows 8 and in Windows 10. It provides a view of all the critical error and warning events from provided in administrative logs. So you can start to see these particular errors and warnings and so on. And the criticality levels are defined by Windows. Information describes a successful operation of a task. Application, driver, service, when a network driver loads successfully, and so on. A warning is not necessarily a significant event, but it may indicate the possible occurrence of a future problem. So for example, when disk space starts to get low. An error indicates a significant problem, so failure of a critical task. A service fails to load during startup. Now, this is general and it's focused on Windows machines, but every organization may have a different level of criticality associated with the events on their networks. So there's also criticality levels additional criticality levels that Windows provides, such as a success audit, the security log, the event that describes a successful completion of an audited security event, so a user logs onto a computer, and a failure audit, as an event that describes the audited security event did not complete successfully, so when the user cannot access the network drive. Now, up until this point, we've talked about Windows systems, but remember that log files are actually ubiquitous across a lot of different systems and applications that are provided within an enterprise environment. And we're also going to talk about UNIX logs. What do UNIX logs look like? So we'll talk about syslogs, which have service and files. Then we have standard log files such as messages or syslogs, authentication logs, WTMP, UTMP, web server logs, Netflow logs, and other logs that are available. So a syslog service is a process designed to handle messages for programs that are syslog aware. And any programmer can use a syslog facility. These store information on a location specified by the syslog configuration file. To use a syslog service, you have to specify selectors. There's two parts, the facility and the priority. The facility specifies a service that has produced the error message. So defined services such as auth, authpriv, cron, daemon, kern, mail, so on and so forth. For instance, the email subsystem log messages would be logged using the mail facility. And it's locally developed code, such as local 0 through local 7. Syslog priority is one of the following. It's debug, info, notice, warning, so on and so forth. You can read the other options here, and it classifies the message by criticality. So there's a particular message that's provided, and then what is the the criticality of each of the messages. The priorities are additive, so messages with a specified priority and all higher priorities will be logged. So for example, the selector mail.warn will match messages with the priority of warn, error, crit, and emerge. Syslog configuration is specified in the configuration file, composed by combining a selector coupled with an action. So an action specified what needs to be done and when a matching message is generated. It could be a file name, a forward to the Syslog service on another host, write the log information to the user's screen, specify the username, and so on. And a Syslog configuration can be seen right here. In the first line, all the messages are in the info are classified as info or higher priority, regardless of the facility. Star.info will be written to the /var/log/messages. Exceptions to this rule are messages from mail, auth-rib, and cron facilities. So you can see that these are all exceptions to the particular rule. And there's a none priority. You can see all the exceptions are up here. In lines 2 through 4, you can see that all messages from specified facilities are written to the respective log files. In line 5, all messages with the priority of emerge, typically only if the system shutdown is imminent, and written to the screen of all users currently logged into the server. And so what does this actually provide? Syslog configuration allows an administrator to specify locations of logs. So where are the logs actually located? And you may choose locations different than the conventional location. And this is actually something that's really important for a systems administrator to do. One of the threats that some threat actors or hackers will actually pose is actually poisoning logs or creating fake logs or flooding logs and that type of thing. And they'll look in the traditional locations that, the default locations that you'll find within a particular system where it's stored. Now, the system administrator can actually store the log files in an alternate location. So when the attacker goes in and looks for the log files in the traditional location, they may not be able to find it. They'll actually have to look elsewhere. And that will actually increase the amount of time it takes for them to get to the information that they want, thus increasing their probability of getting it discovered. In an investigation, what this means is that the var/log directory and the contents are empty. So it doesn't mean that someone has removed them or that the system does not detect log activity. It just means that the systems administrator has been adhering to good security practices and putting the logs in a different location. Now, standard log files. We talked about in the previous few slides, how do we actually use syslogs to go ahead and store logs within a particular aspect of your system. Messages or syslog, there's a default this is the default location for syslog service messages, and messages are designed for parsing standard UNIX utilities. There's the authentication log that's stored here by default, and it records the connection attempts and the results of such attempts. So what actually has been connected to this particular machine and so on. And you want to take a look at these logs to identify whether or not there have actually been brute force connection attempts and so on. Another type of log that you can look at is the WTMP, and it's the historical login and logout information. It's a binary file. You can actually look at this here. So used by other commands, so who are the last logged in users and the last recent reboots and so on. So you can actually see the different commands that are being put in and see the different types of information that's being put out by this log file. Now, analysts will actually use this information to see the login, logout types of rates that are associated with the particular machine, as well as the recent reboots and so on. UTMP are the currently logged in users. It's a binary file. It's located in the var/run or the var/admin file. And the W command from the column is very useful because if an unknown host is seen, you can enter incident response mode. So if you see an unknown host or unknown IP address or unknown user, you can actually start to go in and do some incident response. You can start to identify how did the user get in and go through the preparation, go through your major, the major tasks that we talked about in the previous lecture in terms of making sure that the appropriate steps are taken to feed in the appropriate information and have the appropriate incident response and to relay that information to key stakeholders. Web server logs are probably the most common attack path seen recently. It's accessible to attackers. The access and error logs can be useful sources of data, so you can see who has access to what and what the different responses are for those accesses and so on. And so you want to use this whenever you're trying to look at the different web servers that have been breached and if there's been SQL injections and so on and so forth. Netflow logs are used by equipment vendors to collect IP traffic information. It was developed by Cisco. It can infer the existence of a web server at 222.243 in the example. So you want to watch for unusual ports, excessive traffic volumes, and may indicate illegal downloads. So where this becomes useful is that you're monitoring the traffic in and out of a particular network, whereas the previous one, you're actually looking at a web server. What is the web server generating? What's the data that's being generated from a web server? Are there any indicators within that log file that will actually give you cues that that particular machine has been compromised? UTMP start to look at the different logs or who's currently logged in. WTMP has been who's been logging in or out and that type of thing. Now, what will happen is that with all of these logs, there is the concept of general log configuration and maintenance. So the default settings may not be appropriate for your organization, and different audiences have different needs. So security analyst cares for log in and log out information. So the very first task that you want to do when you're doing your incident analysis is determine the audience. Who's going to be interested in actually seeing the logs and what logs specifically? So there's different granularities of logs that we can think of. There is, the high-level logs that are associated with the network as a whole, the input-output from a particular network. Then there's the logs that are associated with databases, for example. Then there are the log-in, log-out type of logs that are available as well. So who's logging in, who's logging out, what's the information that's stored? We can use a syslog to go ahead and store the appropriate logs in the appropriate locations that's different from the default and so on. So making sure that you maintain the logs is critical. And the first thing that you can do to configure and maintain the logs is know the audience to whom you're going to be presenting the logs to. So for example, a security event log with default settings in Windows 8 early release, it records all the successful logins, so the log will actually fill up very quickly and it'll rotate. The options are to decrease the log file size, do not log the successful logins, you may miss the attacker history, and rotate and archive the old files. So these are the types of things you want to take into account when storing log files, because there could be millions of log files that are being generated every single day within a very large organization. So making sure that you have the appropriate mechanisms in place to store the log files and analyze them accordingly is critical. And speaking of actually storing them appropriately, there's a concept of log consolidation. So you have all of these different devices within an organization that's generating logs. And exporting logs from the original machine to a central box is dedicated to log collection is log consolidation. And it's the best option for security and compliance. It allows for easier correlation of logs between different computers. So sometimes what you'll see is that you'll see the similar type of event happening across multiple computers in an organization. And that could give you a telltale sign that some attack is actually ongoing. For example, a denial of service. So the analyst doesn't have to go around gathering logs from other sources or from multiple computers on their network. What they can do is that they can actually just look at the consolidated logs and analyze them accordingly. It's easy to see all the connection attempts from a particular IP, and experienced hackers clear and disable all logs. So it clears the tracks, but exporting logs in real time to another machine retains a pristine copy, so you don't have to worry about hackers actually removing the logs from the original source. It also prevents accidental deletion, so it can develop access policies for log machines. Now, one of the things that log collection actually facilitates is what's called live incident response. So in the context of what we've been talking about in this lecture and the previous lecture, we talk about, an incident's occurred, we've kind of, taken care of it, and it's always after the incident, that type of thing. But we can also do something that's called live incident response. So you're doing it in real time. You may be automating certain tasks. You have different shell scripts that are set up that will help make sure that the tasks are being done. So live incident response, the collection of both volatile and non-volatile data while the system is still up. So volatile data is data that would be lost on a reboot of the system. And this is something that many forensics experts will say, like, don't reboot the system because then we'll lose all of the volatile data that's in there. So these could be running processes, memory content, TCP and UDP connections, and so on. The non-volatile data is the data that's stored in permanent storage devices such as hard drives. Now, the first rule of forensics is recover as much data as possible while the system is up and running, if at all possible. At times, depending on the damage that's being caused, you have to disconnect the machine from the network before recovering the data because it may be attacking other machines and that type of thing. And all collected data must be shipped off the machine to another workstation, and this is called the forensics workstation. Popular applications can be used such as netcat and cryptcat, netcat will send the data over a TCP connection, and cryptcat is an encrypted version of netcat. System info is usually one of the first commands that's used by hackers. You find out how powerful the machine is and how much storage is available. It also specifies where patches have been applied to the system. Continuing on with live incident response, the collected data must be shipped off the machine to another workstation. This machine is called the forensics workstation. Popular applications that's used to send data, again, is netcat and cryptcat. And system info will be one of the first commands that's actually used by hackers to find out how powerful the machine is and how much storage is available for them. It also specifies which patches have been applied to the system. So you can restore files and obtain files used in an attack, so binaries and logs that are generated from the hackers. One of the key things you also want to look for when you're doing incident response is modification, access, and creation time. So all of these you can also think about as a form of forensic analysis. You're going in and seeing what actually happened in a particular incident. Modification, access, and creation times are associated with data files. So modification time indicates the time that the file was last modified. We saw that from previous screenshots. Access time points to the time the file was last accessed or read. It's not very trustworthy because it's affected by virus scanners and disk defrag applications and so on. So seeing when things were actually last accessed could actually be very, very misleading. Then you have creation time, when the file was actually created. So Netflow logs reveal a suspicious SSH connection to a server. Let's just go ahead and assume that. The Netflow log gives a timestamp associated with the connection. It also reveals a lot of data of what was dropped on the system. You need to identify what was dropped, but how do you search? You build a server file timeline, determine the files created around the time found on the Netflow logs, file, right-click properties, or Windows Explorer for the whole directory. And to examine an entire drive, you can use different types of forensics utilities such as MacRobber. And timelines can help you visualize information about a particular incident. It's a big part of forensics work. So developing timelines on multiple machines, exactly what happened at what points in time, and correlating them with each other with network logs. Example shows a simple timeline. One of the 5 different servers involved in an incident in 2006, resulting in a report that's 15 pages long. Questionable activities on Kenya's server corroborated on other servers, scans initiated on Kenya's server, detected on server A and vice versa, and the entire timeline was built from log files found on 5 servers. So creating this timeline is actually very helpful in incident analysis because you're able to identify exactly what happened when, the exact set of steps that were used in the attack, and how you can make sure that if you've identified those steps in future attacks, how that can actually be mitigated accordingly. Now, forensics is a very, very broad topic and is tightly related to incident response. So the proficiency only really comes with experience. Training is a constant. So computerized devices with network ability expand constantly. So smartphones or to smart thermostats. So I actually am living in an apartment that I've actually set up in a way that has the Alexa smart home, and then also has the the AC and the lights and the door locks and all of that stuff set up. So those types of devices are very different than the traditional types of devices that you see within an organization. So if those devices are breached, and I'm actually doing research into the area as well, what are some of the security vulnerabilities associated with these IoT devices? If those devices are breached, then how do we actually identify them? How do we go ahead and identify the incident that occurred? How do we respond to it? How do we make sure that we analyze it accordingly so we prevent future attacks from occurring again? And some new developments, there's the IoT craze. There's also the Dropbox and Google Drive and Box and all of those cloud technologies that are still relatively new in terms of being adopted within the grand scheme of computing history. And these types of services will immediately share across multiple computers. So files deleted on a computer with a Dropbox or a Box folder are not deleted on the Dropbox web portal. And it's easily restorable. So the question is, how much access does an investigator have to Dropbox logs that require sub-Peona? And the key point that I'm trying to make here is that, hey, we're in a rapidly evolving field, and making sure that we are able to handle the incidents accordingly and analyze them accordingly is very important. Making sure that we also have a touch with the policies that are needed and are most important with that particular incident, and we're coordinating with management to make sure that we ensure the appropriate mechanisms are put in place and proper policies and procedures are being followed is absolutely critical. So this lecture, what we talked about is we got into a little bit more of the incident analysis aspect. Last lecture we talked about the incident handling. In this one we talked about the analysis component. So sources of information that are available within an operating system, both within Windows as well as Linux, Unix systems. So within Windows, we have all those event managers and log files that are being generated there. We can see the the dates of when they were modified and so on and so forth. We can extract information from specific systems and create entire timelines indicating the pattern of an event. And that's very useful to make sure that these events that led up to a cyber attack or that were part of a cyber attack, we can identify them and deploy the appropriate controls in the future. And then we also looked at different examples of evidence of attack on multiple applications, the antivirus, and then how can people go in, or system administrators, security analysts go in and make sure that there are the appropriate controls put in place, or the appropriate researchers put in place to make sure that they these attacks don't happen again. So as always, there is a list of full review questions at the end of chapter 12. And if you have any questions, feel free to reach out to me. Thanks.